So the seventh topic is blood clotting. I've always been amused by how easily our body can heal from a little puncture to our blood vessel whenever we get injected. This made me curious to think what really happens in our body to make wounds heal so fast. This curiosity led me to an answer which I was definitely not expecting. For a process that sounds so simple, yet a lot of factors, as many as 14 factors, and a very complicated process is behind it. But what we are going to deal with right now is going to be the oversimplified form of what actually is happening in your body during the process of healing of wound. So this right here is the oversimplified form, and let's look at it. So firstly, the blood vessel. So here's your blood vessel. And there you go. Okay. Let's suppose at this particular point you have been injected. As soon as you get injected, a puncture is formed at that particular site. And this particular site is the site of injury or the place where the blood vessel has been punctured. From this puncture or from this hole, the blood that is inside blood vessel starts to come out. And that particular condition or that particular process of blood coming out of blood vessel is known as bleeding or hemorrhage. If bleeding continues, loss in blood will take place. If bleeding continues, keeps on continuing, loss in blood will keep on continuing, and finally you might die due to lack of blood. But this does not take place. You don't just die from a simple cut or a simple small wound present on your body. It heals up quite fast. And the reason behind it is blood clotting, which is a very complicated process. But let's look at it from oversimplified point of view. Under blood clotting, two major processes takes place. The first process is your temporary clotting or the formation of temporary clot. During temporary clotting, the clot formation takes place and stops bleeding temporarily. What happens is that the platelets that are present in the blood come together and aggregate together. These are all your irregular, shaped, fragile, sticky, enucleated, extremely small platelets that have come together. These platelets, once they come together, they block the area of injury. So from this particular area, bleeding was occurring, but now the platelets present in the blood have covered it up. This has happened due to the cohesion of platelets. Since platelets are irregular in shape, they can easily fix on one another. They can easily fit with one another. And secondly, since platelets are sticky, they have great power of cohesion. After the formation of temporary clot or after temporary clotting, the bleeding has stopped for right now. Then the process of permanent clot formation takes place or permanent clotting starts. Permanent clotting. Now here's the thing. During injury, clotting takes place. But there's something in our body that is against clotting or against coagulation, and that's your anticoagulant. Since there's anticoagulant in your body, it's gonna hinder with the process of clotting and does not and will not allow clotting to take place. Then how does clotting even take place if there's someone who doesn't want clotting to take place in your body? It takes place because that someone or something that does not want clotting to take place in your body becomes inactive. This is how. So the anticoagulant present in human blood is heparin. Heparin works against clotting or coagulation. The heparin at the site of injury comes in contact with air. Once it gets in contact with air, it gets oxidized, and the oxidation of heparin leads to its inactiveness, or heparin becomes inactive once it gets oxidized when it comes in contact with air. That's your first step, and the first problem is sorted out. Second step, now the actual clotting process starts. The platelets, they are fragile. These fragile platelets, they rupture or tear easily. Once they rupture, they produce something called thromboplastin. This thromboplastin, step 3, thromboplastin gets converted to something called thrombokinase with the help of calcium present in your blood. And this thrombokinase is very important to activate the inactive clotting factors present in your blood. Since thrombokinase is important, the stuff required to convert thromboplastin to thrombokinase is important, and that particular stuff is calcium. So calcium is not just important for bone strengthening, but also for clotting of blood. Where do you need calcium? You need it to strengthen your bone. You need it for blood clotting, and you also need calcium for muscle contraction. In the chapter of muscle, you'll come to find out why calcium is necessary for muscle contraction. Muscle clotting. Oh God. I get too nervous in front of camera. Still not used to it. So sorry for my mistakes. So calcium is required to strengthen your bone. It's required for blood clotting and also for muscle contraction. Okay. Now, what did I say? Thrombokinase is required to activate stuff. What stuff? The clotting factors or the clotting protein present in blood. So firstly, there's prothrombin, which is a clotting protein present in plasma of your blood. Prothrombin is the inactive form of thrombin, which you can find out or see from the part pro. Prothrombin is the inactive form of thrombin, the same way prorenin is the inactive form of renin. This prothrombin gets activated with the help of thrombokinase into thrombin. So thrombin is the active form of prothrombin. Then, fifth step, there's the second clotting protein present in the plasma of your blood, and that's fibrinogen. Since it has the part gen, it is the inactive form. Fibrinogen is the inactive form of fibrin, the same way trypsinogen is the inactive form of trypsin. This fibrinogen gets activated with the help of thrombin into fibrin. Fibrinogen and prothrombin, they are the clotting proteins that are present in the plasma of your blood from the beginning, but they are in inactive form. They get activated with the help of stuff or these chemicals. Thrombokinase activates prothrombin to thrombin, then thrombin activates fibrinogen to fibrin. Fibrinogen that is present in your blood is present in the form of single fibers. Let me draw fibrinogen. So here's your fibrinogen present singly. Here's your another happy fibrinogen present singly. Once this fibrinogen gets activated to fibrin, it forms a mesh or network-like pattern. Basically, one fibrinogen holds hands with other fibrinogen, just like this, together. Here as well. Since they are holding hands, it looks like a network of fibers. And this network of fibers right here is known as fibrin. So it's present in the form of a network. This fibrin, along with the dead cells at the site of injury, because the cells are injured, due to injury they have died, and along with the dead cells, the fibrin forms the clot or a thrombus. This thrombus or clot, what it does is, it goes at the site of injury where the temporary clot is present and patches itself up or covers it just like this. So here's your network or fibrin, and then in between these fibrin are your dead cells. This fibrin or the network of fibers along with the dead cells form a clot called thrombus, and this thrombus covers up the site of injury, forming your permanent clot. So this is your permanent clot. After the formation of permanent clot, no bleeding takes place. The clotting factor prothrombin is produced by your liver, and for liver to produce prothrombin, it requires vitamin K. That is why vitamin K is extremely necessary for your body for the process of blood clotting. That is why vitamin K is essential for blood clotting. Deficiency of vitamin K can lead to bleeder's disease. Not just deficiency of vitamin K, deficiency of any one of the factors can lead to a disease where the person keeps on bleeding even when he gets a very small cut, and that particular disease or disorder is known as bleeding disorder. The name of that disorder is hemophilia. Hemophilia is a condition. What type of condition? It's a condition of continuous or non-stop bleeding, where the victim, the patient, even when he or she gets a small cut, the blood won't stop to come out of it, or blood clotting just won't take place. It just doesn't want to take place. That is due to absence of any one of the important stuff that helps in blood clotting. Okay, let me revise the whole process for you. Blood clotting. Whenever there is an injury to your blood vessel, blood starts to come out, and that particular situation is known as bleeding. Bleeding stops due to blood clotting. During blood clotting, first temporary clotting takes place, where the platelets present in the blood, they aggregate at the site of injury and stop bleeding temporarily. Then the process of permanent clotting starts, where the anticoagulant present in the blood first gets oxidized and become inactive so that it does not hinder the process of clotting. Secondly, the platelets, since they are fragile, they rupture and produce thromboplastin, which gets activated with the help of calcium present in your blood and form thrombokinase. Thrombokinase helps to activate clotting protein prothrombin secreted by your liver into thrombin. This thrombin further helps to activate fibrinogen, the other clotting protein present in your blood, into fibrin. Fibrin is a network-like structure of fibers which along with dead cells forms clot or thrombus that patches the region of injury or cover the region of injury, forming permanent clot and permanently stopping bleeding. And that's it. Bye.